Good evening, everyone. So, in yesterday's live stream, we saw the basics of try catch, that is, the basic of exceptions. Today, we'll be seeing some more details and then we'll be putting everything in a nice example so that it makes more sense. That is, we'll also apply these theoretical concepts in a slightly realistic program. Okay, so let me create a new file for today first. So, I'll call it nested demo because that's what I'm supposed to do now. I'll create a nested try catch first. So we'll have the main first. So this is our main method. And within the main, I'll have a try block. And please note, there is no sense in having just the try block alone. If you see over here, it says syntax error, insert finally to complete block statement. That is, we can't have try alone, but we can have a try with a finally. And obviously, we can have a try with a catch. And we can have a try with both the catch and the finally. So these are the three possibilities. So we can have this as well. So just a quick recap. Computer will try to execute whatever is there in the try block. If there is no exception, it will go to the finally block. If there is an exception, it will go to the corresponding catch block, and then it will go to the finally block. Another thing which I would like to emphasize today, which I never mentioned yesterday, was that the exception class is the base class of all exceptions. That is, if I have the line catch exception E, then it will catch no matter what the exception is. For example, in this case, let's have a few print statements. So I'll say inside catch block, and then here I'll say system.out.println inside try block, and similarly over here I'll say inside finally block. So if I run this program right now, there are no exceptions. So computer will first go inside the try block, then it will go inside the finally block. Let's run it for the sake of completion. So we'll run it. And as you can see, the control is first going inside the try block, then the control is going inside the finally block. Let's throw an exception. So we now know what is a throw statement. So what we'll do is we'll throw the exception directly. So suppose I say throw new, and then I say, let's say arithmetic exception. So I'm creating an arithmetic exception and throwing it directly. So now what will happen? Computer will go inside the try block, exception will be thrown, computer will go inside the catch block, and then once the catch block is over, it will go inside the finally block. Let me run the program again. So as you can see, inside try block, inside catch block, inside finally block. So this is how the thing goes. Now, notice what is happening. I am throwing the exception, arithmetic exception, but it is going inside the catch block. And the reason for that is that the exception class is the base class of all other exception. So no matter what the exception is, it is a type of the base class exception, that is an exception. And hence we say that this is a catch-all block. This is something known as a catch-all block, and it can catch any exception. Now let's say I want to catch the arithmetic exception. So what I can do is I can have one more catch. I can say over here catch, and then I'll say arithmetic exception E, and then I'll just align it properly, and then we'll have one more system.out.println over here, and here I'll say inside arithmetic exception block. So now notice what is happening. We have two catch block. One is trying to catch the arithmetic exception and the other is trying to catch any other exception. So what will happen is computer will start matching one by one in the order given. So what will happen is that once this exception is thrown, the first catch block will match the arithmetic exception, computer will go inside the catch block, and then it will go inside the finally block. It's not going to go inside the second catch block because it has found a match. So once a match is found, other catch blocks are not tested. Let me run this for you. So if I run this once more, see what happens. We are inside the try block, exception gets thrown, we go inside the arithmetic exception block, and then we are going to the finally block. So that's one thing. Now Aman has a question. He's saying in the chat that is exception block like if else? Yes, you can say it's like if else in the sense of the ladder. It checks one by one. Once it goes in one of the if blocks, it's not going to test the other block. So yes, in that sense, the behavior is the same. Okay. Now another thing which I wanted to show you, that this catch exception E thing, that is the catch all block, should not be the first catch block. Like for example, if I do this, please understand, since this catch block can catch anything, the subsequent catch block does not means anything. Like for example, if I point out over here, see, unreachable catch block for arithmetic exception. The thing is, the first catch block, that is exception E, can catch anything. So if it can catch anything, the other catch blocks are useless. So this is not allowed by the Java compiler. So if you are having the catch-all block, it has to be the last one. So this is how it usually works. So let me run this once more just to ensure that everything is okay. Okay, so everything is okay. That's not a problem. Okay, now the other thing which I wanted to discuss was the nesting. Like say for example, if I copy this entire try block and then I place this inside this other catch block, and obviously we have to get rid of this line. Now notice, within a try we have another try, and let's say we call it inside, just to differentiate which one is which, we'll say inside inner try block, inside inner arithmetic exception block, inside inner catch block, and finally inside inner finally block. So now try to understand what happens. Computer will attempt to execute this try block. Inside this try block, an exception is being thrown. This exception will be catched by this catch block, and then computer will execute this finally block. And once this whole try block is over, this outer finally block will also be executed. Let me run the program again. So I go over here, I compile, and let us see what is happening. It is going inside the try block, the outer try block. Then it is going inside the inner try block like we discussed. Then an exception is thrown. It goes into the arithmetic exception block. It goes to the inner finally block, and then finally it executes the outer finally block. Now let's say there is some scenario where you want that this outer catch block, that is catch arithmetic exception E, should also get to handle the same exception. There is one trick which you can use, and that is, once this is done, I can re-throw the exception from here. I can say throw, and whatever was passed, I'll throw it again. So now what is happening? Once the catch block of arithmetic exception handles the exception, right now we are simply displaying the message, we are throwing it again. So see what happens now. If I run it once more, see, first the outer try block is executed, then computer goes to the inner try block, then the inner try block throws the arithmetic exception which is caught by the inner arithmetic exception block, and then the inner finally block executes, because finally block always executes after the catch block. And then we go to inside the arithmetic block of the outer try block, and finally we execute the outer finally block. So this is the flow. The point to be emphasized is that finally block is always executed once the catch block is done. And if you are rethrowing it, the outer try gets to handle the exception as well. This is one point which I wanted to emphasize. Now, the other thing which I wanted to emphasize is what happens when a function call another function and that function calls another function and an exception is thrown from the third function. So now what we'll do is, to reduce the clutter, I'll create one more file and we'll call, let's say, deepcall.java. I'll close the other two files for the time being. We don't need them now. And then we'll have one more main over here. So what I'm saying is that we are calling a function f1 from main. That means, sorry, not f1, or let's say f. We'll create a function public static void f. From within this function f, I am calling another function, let's say g, and then we'll define another function by the name of g. I'll say public static void g. So once this is done, inside g, now I'm going to throw an exception. So I'm saying throw new, and let's say this time again we throw the arithmetic exception. So notice what is happening. We are throwing arithmetic exception and we are inside g. So what will happen is we are throwing an exception. We are not doing any handling. The exception will go to the function f. Here also we are not doing any handling. The control will go to f, or rather the main. Let's run it and see what happens. So if I run it, so notice the stack. At the lower level, you had the main function. Main called the other function that is f. F called the other function that is g. And we finally got the arithmetic exception over here. Now, please understand, arithmetic exception is an unchecked exception. Computer does not checks for it. If we throw an exception which is checked, see what happens. So instead of arithmetic exception, I'll simply throw exception which is a checked exception. Now see what happens. If I compile it, it's not going to compile. There is an error over here, and error is unhandled exception type exception, which means that if you try to throw any exception which is a checked exception, compiler will not allow you to run the program till you either have a try block over here telling the computer that you want to handle it, something like this. So if I say try block and then I close this try, and let's say I have simply a finally block over here. So now, wait, we are not handling it. So finally won't cut it. So we'll say catch exception E. So now see, the error is gone. So in case of a checked exception, either you use try block, that's one scenario. This is what we are doing right now. The other possibility is, I'll just say undo a few times. The other possibility is that over here I say throws exception. That is, I'm informing the compiler that, okay, I am aware that the function g may throw a new, that I'm aware that the function g may throw an exception by using the throws clause. But now the thing is, we are getting an error over here. So the point is that if a function is throwing a checked exception, then everyone from that function till main has to either have a try catch or have a throws. So like, for example, if over here I put a try block, I say try throws new and then I say catch exception E. Now the moment I do this, this problem gets resolved. So this is my point. And let's say I'm not doing this. Then the other scenario is I have to say throws exception over here. as well as a throws exception over here. So this is the point which I was trying to make. Now all the basics are out of the way, and now we'll create a full-fledged program to see how things are applied in a real world program. So for that, what I'll do is I'll just use some code from the first class. I'll just say demo.java, and I'm interested in this portion of the code right now. So I'll just copy paste this, and then we'll say, let me think of a nice name. So we'll just call it example, because that is what it is, example.java. I'll first create a main method. I'll close the sidebar, and then I'll paste this. Now let's see this. So I don't need this line. I don't even need this right now. I don't even need this line. Okay. Now notice what is happening. We are asking the user to enter two fractional numbers. Then user will enter the two numbers. The first number is stored in the variable number. The second number is stored in the variable divisor. We are finding the quotient and the remainder, and then we are printing the answer. Now see what happens. Let me run the program directly without any issues first. So if I run the program directly, let it compile. Okay. And I say 5 and 2. Computer is going to display the answer. Quotient is 2 and remainder is 1, which is perfectly okay. Now I'm going to run the program once more, and this time I'll cause an exception. That is, I'll say 5 and 0. So if I press enter, computer is going into the exception block and nothing is happening right now. It is not crashing the program. Like for example, if I remove this catch block, the program will crash. Let me show it to you. So if I remove this and I say run the program will crash with the message, or rather with the exception. See, this is abruptly ending, and that is what the definition of a crash is. The program ended abruptly with the message arithmetic exception division by 0. Now what I want in this case is I really want to handle the exception. That is, once this happens, I think it's a better idea to inform the user that, okay, the divisor cannot be negative and you need to enter the numbers again. So what we'll do is first we'll display the message that what went wrong. So we'll say divisor shouldn't, let's say divisor must not be 0. And then we'll tell the user what to do. We'll say try again. So this is our message to the user that, okay, this problem has occurred, that is divisor must not be 0, and we are saying you should try again. Now the thing is, how will the user try again? So what we'll do is we want the user to keep on entering values till the correct values are entered, and for that what we'll do is we'll put this whole thing inside a do block. Please recall, do block means that I'll remove the finally for the time being. Do block means that the body will be executed at least once. So we'll have a do block over here. And right now I am saying that this is an infinite loop. So now what is happening is that the program is going to go up again. But we want it to stop once we get the proper answer. So for that, what we'll do, we need some sort of flag. So for that, we'll say that, okay, Boolean, and we'll call the flag as input okay, whether or not the input was okay. The initial value of input okay will be false. And if the input is really okay, we will be able to reach this last line of the try block. And here we'll say that input okay is equal to true. And now we'll over here where we are saying just true for the time being, we'll say while not input okay. So now see what happens. The loop is going to keep on running till input is not okay. Input will only be okay once the output is displayed, and then the program will finish. Let's try to run this program once more. So what we'll do, we'll go over here, we'll run the program, and let's say I cause an exception. I'll say 5 and 0. When I press enter, it says divisor must not be 0. Try again, and then it is waiting for me to enter the number once more. So let's say I say 50 again. Again, it's not working. If I say 52, the program works and we get our quotient and remainder. Now, if you notice, it would have been better if this message was displayed again. So we'll make a small change. We'll go up. We'll find that line which was over here, and we'll move this inside. So we'll go over here and we'll place it over here. Now the program will look good. But now we'll cause one more problem. So let's first run the program once more. So I say 50, computer complains that divisor must not be 0, try again. I again say, let's say 60. Again the computer complains divisor must not be 0, try again. And this time I try to be over clever and I say 5, 3. Now notice what I'm doing. I'm giving the second number as a string. So if I press enter now, we are not handling the input mismatch exception. So if I press enter, there we are, it is throwing the input mismatch exception. So what we can do is we can handle this as well. Or like sometimes you might have seen in real programs, you might have a catch-all exception and say some unknown problem has occurred. But we won't be doing that unknown problem stuff. We'll actually be handling the second one also. So we'll say catch input mismatch E, and then over here we'll say you must enter numbers. So input must be an integer, and then again we'll say what you need to do. We'll say try again, and this time, wait, what's the error over here? Input mismatch exception E, it's giving an error over here, and the error is input mismatch exception cannot be resolved to a type. And that is happening because we only imported the scanner class. We have not imported the other. We can either say import java.util.input mismatch exception, or we can simply say that instead of scanner, I want all the classes of that package. So we'll use the easier approach right now, though it's a better practice to just explicitly state what imports are required. So now if we go down, we are catching the other exception also, and we are displaying the message. Let's run the program once more. So it is asking us to enter the number. I'll say 50, try again. I'll say 50. Now see what is happening. It is saying enter two fractional numbers. Input must be an integer, try again, and then it has gone into a loop. The reason that it has gone into a loop is that, now this is something interesting. We are entering a number, we are pressing enter. We are entering the next number and we are pressing enter. This is okay. But once we say, let's say 5 and ZERO0, the second input is a string. That string cannot be stored in the divisor, but it is there in the stream waiting for it to be picked up, and it's never get picked up because next time also we are getting in dot next int. So what that 0 which was entered remains at the beginning of the stream. I'll just explain this with the help of a diagram so that it's clear. Let's give me a moment. I'm just waiting for the scribbling software. Okay, there it is. So what I'll do now is just try to understand what is happening in this case. So we have an input stream. The name of our input stream is in. We entered two things. We entered 5 and we entered 0. The first variable 5 went into the variable number. That was not an issue. This went over here. The second variable was divisor, which was an integer. what is happening over here is that this 0 cannot be stored in the variable divisor. So 5 is removed from the stream. 5 is gone, but 0 is still here. The next time we go up over here, that 0 is still there, and that is causing the input mismatch exception in loop. So what needs to be done is that once we get an exception, we have to remove this 0 so that next time we can start with a fresh set of input. So what we'll do now is we'll go over here, and when we have reached over here, we'll just say in dot next line. Next line will remove everything till the enter key. Let's run the program once more. So if I run this program again, and again we do the same thing, 5 0, divisor must be 0, try again, and then we say 5 0, and now this is the proper thing, input must be an integer, try again, and the program will keep on asking us till we enter a sensible set of values. So this is one proper example where you can see how you can make a very robust program which can survive mischief or whatever you want to say, or errors. This might be a genuine problem also. Let's say the user is not able to understand what the input should be. So in that case, we have a very robust program which will not take the wrong input, neither in terms of a 0 as a divisor, neither a string or something else as an input. So that's all I had in today's agenda. If you have any questions, you might leave them in the chat. So I'm waiting if there are any doubts. Otherwise, we'll close this session. So it seems to me that there is no issue. So that's all for the day. And in tomorrow's class, we'll be discussing in detail. Now, please note, tomorrow's class will be on point number 5, that is primitive values, wrapper classes, types, and casting. And there is a common misconception that this is something very simple. I do agree that it is very simple, but there are certain things which might be problematic if you are not attentive. Like, I'll give you one example. Like, we say that A is equal to A plus B is same as A plus is equal to B, but there are exceptions where this is not the case. So we'll discuss these kind of things in tomorrow's session. That's all for the day. Thank you.